and gentlemen, wherever you are. I'm Lothar Rieske. I'm lead enterprise architect at Fujitsu Technology Solutions. I live and work in Frankfurt, and I'm in the practice for application modernization. I started conquering the topics container and Kubernetes about 5 years ago, perhaps a bit longer. And I came across quite some changes and evolutions in the Linux ecosystem. So I had in mind to give a talk on a landscape view of the evolving ecosystem. Let's start it. Linux has brought a broad evolution to the domain of not only operating systems, but even with respect to the hardware underlying operating systems. It's fair to say, I think, that it's one of the biggest open source projects, perhaps even the biggest one. It has driven cultural things like sharing economy and topics like that. And we have seen evolving quite large set of different Linux distributions. So Linux had some time to evolve. But we have seen on this journey the development of under-topics, of undergroups of Linux. One, perhaps 7 to 8 years ago, was a development heading toward minimal Linux. Linux systems had become very, very large, so installation DVDs usually took 4 to 5 gigabytes in size. That's large. And people started to think about how can we shrink Linux systems. That came to the idea and the notion, and I like it, JUICE. It's a bit strange pronunciation of the 4-character acronym on this slide. The acronym stands for Just Enough Operating System. So really thinking about what is necessary in Linux. And this came at a time when virtualization technology has won several things in data centers. And with virtualization, one of the benefits is that you have smaller sets of storage and network and other devices. So the drivers become a bit more standardized, and you do not need that large number of them. So this was a development heading towards minimal Linux systems. Linux systems minimized for smaller size, not only to save disk space, but also to have reduced attack services, because everything in a system that can be thrown out of the system is one target that attackers cannot use anymore. So when we look at the whole Linux landscape, we have a whole set of distributions. Let's call them generic Linux. This led to a development like minimal Linux. Many of the distributions had such variants of their Linux distributions. Not all of them, but most. And now we are facing a new era heading toward container Linux. And these 3 categories do not substitute each other, but they develop in a direction where they live beneath one another. So I found a definition for container Linux. If you say container Linux, you have a very short description of what is essentially meant. Essentially meant is the operating system on the container host. So if we would look into container images, this would be a different story. This is another strand of evolution in the Linux domain. You see candidates there like BusyBox or Alpine. You would perhaps not call them Linux any longer, but this is a different area of development. We are talking about host operating systems, and the National Institutes of Standards and Technology in America, NIST, has put together this short description that there is the most important parts about that. I will read it to you. A container-specific host OS is a minimalist OS, explicitly designed to only run containers with all other services and functionality disabled, and with read-only file systems and other hardening practices employed. When using a container-specific host OS, the attack surfaces are typically much smaller than they would be with a general-purpose host OS. So there are fewer opportunities to attack and compromise a container-specific host OS. Accordingly, whenever possible, organizations should use container-specific host OSs. This is what I would recommend to you as well. And in the next few slides, I will recommend to you how to choose a specific container-specific host operating system. When we look at this slide, it shows you the two pioneering operating systems. Minimal Linux is specific for running containers. It were CoreOS and Rancher OS. CoreOS, the product, the container Linux, has the same name as the company. This often led to confusion, but let's stay with it. It's a bit simpler with respect to Rancher OS. The company behind Rancher OS is called Rancher Labs. And I thought I compare these two and talk a bit about what they did similarly and where they really are different. With respect to initialization, CoreOS took the standard Linux approach with systemd, and Rancher OS minimized there further and went to implementing a special initializer. So they decided for a custom solution for initialization of their system. With respect to configuration, you have the usual procedure of virtual machines in the cloud that find a cloud init file that tells them how to configure special things, let's say accounts, let's say file systems, formatting file systems and stuff like that. These are things that can be described in a cloud init file. And CoreOS decided to do something similar, but a bit different. They call it ignition, because this is what makes the pure operating system specific to the instance you are just installing and initializing. Distribution was a major step away from the approach standard Linux distributions take, because standard Linux distributions, all of them have their package manager. CoreOS and Rancher OS took the decision to get rid of package managers and go only image-based. That means the whole CoreOS distribution is distributed as a blob, as a binary large object, and this makes operating system upgrades in these two cases a bit special, because you do not simply update many packages. Sometimes you have to reboot after the packages. In this approach, you really override the whole image. You do not really override it in place. The system is one where you have two partitions, one with the image that is just booted and booted successfully, and you poll in certain frequencies backend servers for new images, updated images when one is available. This new update is placed on a second partition, and when it's downloaded in full size, you go to reboot of the system. The reboot checks whether it is successful. If it is successful, these two partitions are swapped, and the new one, successfully booted, takes the role of the former old one, and you can start again, start over. Just wait until the next update is available. with respect to containerization, these pioneering systems started during a time where Docker was the dominating software for running containers. But you saw with respect to CoreOS that they will create a new competitor for Docker. Let's say competitor, because the whole community was dissatisfied that Docker took the only implementation approach. And if you follow the discussion then, the dispute was about whether you do implementation or specification up front and then implementation. And one of their approaches, going the specification way, was this Rocket container runtime. And meanwhile, nobody really talks any longer about Rocket, but this has to do with several development. I think it was an interesting thing, but in the beginning, CoreOS as well took Docker as container runtime. So what these pioneering systems did, we then saw this is a new category, and the classical Linux distributors started to get into this field as well. On the next slide, I took the same categories like before: initialization, configuration, distribution, and containerization. And in the top row, you see what operating system I'm talking about. There is Fedora Silverblue and Fedora CoreOS. And we have from Rancher Labs a successor of Rancher OS. It's K3OS, and we have from SUSE the Micro OS. So you all know that CoreOS was bought by Red Hat. So Red Hat has no longer only the old Fedora system, but had a Project Atomic distribution of Linux, as well as container Linux. This is meanwhile renamed to Fedora Silverblue, and they have to think about what to do with the Fedora CoreOS approach. And if we now go through it, you see systemd as the initialization for both of the Fedora systems. For configuration, they are a bit different. Silverblue takes a cloud init approach. Fedora CoreOS takes again an ignition approach. But if we look at the row with distribution, then we see that they step back to a package-based approach. The package-based approach with both systems is, from my point of view, a step in a direction that's not a positive move. Because if you try to work with these systems, then you get into some trouble because you do not really work with these systems as you worked before. It's not any longer you just install packages, but you have now special mechanisms where packages are something like pre-installed, and you have to reboot the whole system to make the package really available and working on the system. So these complications come together with the current development. We will see, I think, in 2 to 3 years, most of these Linux distributions will have read-only file systems, and there is some interaction with these two paradigms, and in the moment, I think it's a bit complicated. As we are in the Red Hat world, we can directly see containerization is done with the container runtimes Creo. So let's get to the column with K3OS. What has become of Rancher OS? We again see that we have a custom initialization procedure. They do the cloud image approach, but they again decided to go toward an image-based distribution. They are away from Docker now as well, and they use containerd as a containerization runtime. Micro OS is a bit more of a classical distribution. It's a system D1. They have a bit of further evolution of the ignition approach. They call it combustion. They are as well a package-based system, and they again used the containerization with the container runtime trio. So looking at this, it seems that the classical Linux distributors that bought and merged with the new container Linux providers in the distribution column brought them forth doing again the package-based approach. And we will see on the next slide that this has not to be the only choice right now. With respect to containerization, I think the stronger trend in the moment is toward the container runtime trio, because K3OS is the single one with the container D approach, and K3OS does some things different as well. Some are good, but it's a bit more of an opinionated system. There are other container Linux systems I could have included in this overview. For example, Kinvoke has done a fork of CoreOS. Meanwhile, Kinvoke is bought by Microsoft, so I think we have to wait a bit to see what will become of the Flatcar Linux they brought to the market. There was a development of VMware. VMware had a container Linux project called Photon, and there are others around there as well. But I think the most prominent one, because we have those roots at classical Linux providers, are with CoreOS. And in the commercial aspect, this is included as Red Hat Enterprise Linux CoreOS in OpenShift. And with macOS and K3OS, I think we have to wait a bit how the acquisition of Rancher Labs by SUSE, whether they convert those two approaches or whether they remain distinguished. We will see. The important thing is that with stepping back from image-based distributions back to package-based distributions, we have this difficult relationship between how do we updates. And atomic updates and transactional updates are far more clear if you have an image-based approach, because you have this thing with partition swapping and nothing else. And with transactional updates, you again think in, I update package for package for package, and then I have to do something like bracketing to have a really clear view on how many packages have been updated and how many updates were successful. And if one was not successful, whether I can roll back several updates. And you see, this can become complicated, and I think it is better to have this approach with image-based. This is my opinion, and from working with those systems, I would recommend to you going in this direction. The other thing is that Linux distributions right now tend to get more towards new file systems, and especially read-only file systems. So the ButterFS is one development in this direction. Some of the Linux distributions actually have done this already. Others are heading toward it. So I think we have a bit of an unstable time with respect to that as well. Maybe that's another reason to go with respect to Kubernetes in the direction of image-based distributions. If we look at the whole development on this slide, you see on the bottom the two big distributors, Red Hat and SUSE, and see the two lines, the project Atomic that evolved into Silverblue. So the reading is, evolution is top down, And on the second column, you see that CoreOS was the company, and Container Linux was their marketing name, interchangeable with CoreOS. So it was the beginning of their marketing. This has become, meanwhile, Fedora CoreOS. And if you look at the one slide with the library, you see that they had certain design decisions. Many of these design decisions have changed, meanwhile, with respect to Fedora CoreOS. So I think there are different things, even if the name, in part, at least, is the same. And with respect to SUSE, you have the traditional evolution thing around MicroOS. And you have, with respect to the merger with Venture Labs, the developments around K3OS, which is as well the foundation of their Kubernetes distribution. And I think with K3OS, you not only decide on the operating system level, but you decide for the Linux distribution there as well. Because I tried to bring other Kubernetes distributions on top of K3OS, and this is not that easy and self-explaining. So the talk could end if we do not have another development. Meanwhile, these three companies are not only big cloud providers, but they are real innovators for the IT technology. They are the biggest they operate the biggest data centers I think have ever built. And of course, they have a mind with respect to operating systems as well. And if we look at that, we do not see that much about Azure and Google Cloud, what operating system they use and what their internal development of these systems are. They are, at least in part, in open source, but I see the more clear strategy right there is the strategy of Amazon. You see, for example, if you go Google Cloud, that they have something they call COS, Container Optimized Operating System. And this COS had its roots in the Google, in the Chrome OS. So it's a very special development as well. You can see parts of that in GitHub, and the same is true for Azure, but Amazon has done more. Amazon has launched a container operating system called BottleRocket about 3/4 of a year ago. This was a big message to the market, and what they decided and what their design is really attracting. Let's look at it. First, it's in GitHub. I do not know another distribution which lives that open in GitHub. BottleRocket OS, it's only 6 repositories. You see the operating system at itself, BottleRocket. You see that there's an SDK, because BottleRocket has the philosophy that you can build variants of it. BottleRocket SDK is the tooling around that. You see that BottleRocket uses 2 container runtimes, and BottleRocket Control Container is for the one runtime. It's a normal one, so to speak, and BottleRocket Admin Container is a more specialized one. If you want to go really deep in operating system for debugging purposes or stuff like that, you would go with the admin container, and you have an update operator doing all that stuff about images. I listed some of the features right here. It's a 5.4 kernel with just enough user land. So we come back to the idea of minimal Linux and just enough operating system. Things are primarily written in Rust. That means by throwing out certain parts of the system, the parts remaining in the system are rewritten in a more secure implementation language. Many projects, meanwhile, take the decision to go more in the direction of Rust. They use C groups and namespaces. This comes with typical container runtimes. And they additionally make use of extended Berkeley packet filters, which is interesting as well. Especially, I think you have to look at Linux distributions like the kernel has to provide eBPF. For example, if you want to install CNIs like Calico or Cilium, you have to have that. They have an immutable root file system, nothing towards the direction of BetaFS. They take cryptographical measures to secure it, and they hinder write access to it. They leverage the update framework. That means they have not invented their own story like CoreOS did and BranchOS did. It lives in the open source world on GitHub. Everybody can clone it. And we have those two separate container instances, control and admin. And the line at the bottom is, I think, the most important one. You can build your own variants with that. And you are invited to do that. That's why they put everything in GitHub. So I talked about container host Linux. I included the host word right here to be a bit more explicit. We learned about the pioneers, CoreOS and BranchOS. Then looked at the more mainstream container host Linux variants, Silverblue, CoreOS, K3OS, and MicroOS. Then I introduced to you BottleRocket, and I think we can see something like a mainstream that the incumbent distributors go in package-based directions, but that BottleRocket revitalizes many of the original BranchOS ideas. With that, I want to thank you and wish you a nice SUSECON. Goodbye.